for joining me for geometry at the Ingram Library at University of West Georgia by me, Pharaoh Ingram. So their next first object is our lovely circle. The set of all the points in this plane that lines the same distance from the given point. This is what a circle is. All the points are the same distance to the outside of the plane. So next is our square. Our square is a rectangle with all congruent sides, or equal sides. And so next we have coming up another lovely square here that I found on the second floor of our window. And then next I have a rhombus, which is like a square, only in this case the angles are not necessarily 90 degrees. The next we have a rectangle, which is a quadrilateral with two pairs that are equal of those four sides with all right angles. The next I have another collection of right triangles, more rectangles. So they're all around in this picture. You can see if you can find it. The next we have our parallel lines. Our parallel lines run next to each other at the same distance, going in a similar direction, but spaced out evenly. And then we have our perpendicular lines, which intersect each other at a 90-degree angles, which we can see that with the books and the collection stacks. And then our cart also has those perpendicular lines. And next coming up, we have our dihedral angle, which is a union of two half planes, a union of these stacks against the books and against that wall there as well. And then we also, looking at this sign as well, we can see the dihedral angle. And then we have our acute scalene triangle, which all the sides are not the same, and they have acute angles of this triangle. And then another one here, if we look between the space of the picture against the wall. And the same thing goes on with these pictures hanging on the wall. This was at the second floor. So, and then next we have our isosceles right triangle. Like if we took that line from that wall and ran it straight to the bookcase, we see a 45-45 of those 45-90 and of those sides. And then here I have an irregular pentagon, which we see a five-sided figure behind this table that is folded up. And then next we have coming up this hexagon, which we see has in our trash can that we have 6 equal sides. So this is a regular polygon. And then next we have a prism, which is a polyhedron, which in two congruent sides lie in parallel planes, and the other faces are bounded by parallelograms. And then I have another one that I also found on the first floor of this regular rectangular prism. So we have our sphere, which is, and then we have a cone, which is at base of a circle and then meets at the point at the top. And then the cylinder, we have those two circular bases with the height, and then a pyramid, which if we took those at those four corners and made them up at the top meet the same vertex, we would have a pyramid. And I also found another one in this vent here, which if I were to fill that in, we would also have the pyramid, which has that same point of the vertex from those four corners. So next we have a figure that shows point, rotational, and line symmetry. Those line symmetries, there can be more than one here. We have a point, which has less than 60 degrees if we turn it for the rotational, and then for the point we can also get something of 180. And then here also for these handles that turn these cases around to move them, also have rotational line and line symmetry as well. And then another screen of a kaleidoscope, which we can all do this for the same different types of symmetry, all three. And then coming up we have a tesslation, which covers up playing with the copies of the figure in such a way that there are no gaps and no overlaps, which we see in all these rectangular tessellations here. And I also have this parallelogram tessellation in this picture here that I found on a step ladder on the ground floor. And here is an example of an area, which we can do an area application by looking at each section of this big huge bookcase in front of the circulation desk, and we can do estimation of finding the area for this space. Then here I found a parallelogram, which is not necessarily don't have the 90-degree angles, but they have the two parallel sides, equal sides, and then the other two equal parallel sides. And I'd like to thank you for joining me geometry at the Ingram Library. Thank you.